Young people, welcome back. In house. What we got today, y'all? You got chapter 7, lesson 5, exponential functions. The learning objective, graph exponential functions. Secondly, identify data that displays exponential behavior. Got it. So students will be able to graph exponential functions. The concept is exponential functions and the skill is graphing. Let's get right into it, guys. I love this handout. Looks short, but nothing too short about it. Meaning, just having a good understanding of the concept, exponential functions. First word, exponential, second word, functions. So I'm gonna start off with a pause, nice and early, guys. And if you've been in these videos, you kind of know. So we're pausing because concept is key. If you don't understand the concept, you're gonna be lost for days. The skill is also key because you got to know what to do with that concept. So right now we're talking about exponential functions. The function we've talked about, we've been around, the function of x. All right. So ideally, guys, y. Y equals the function of x equals. Similar, same thing, but exponential, of course, means exponents again. All right. So an exponential function referring to a function that is being taken to a power, right? An exponential power. So what we're going to be doing, guys, is we'll be graphing, and one of the best ways to graph, guys, is using a table. So as you can already see, wow, I'm going to be using tables in order to show and describe what these graphs will look like. And exponential, growing really, really fast. So let's keep going, guys. So first thing I want to point out is you see that I have an x, y table. So inside of the x, y table, right between it, I'm going to go ahead and put the exponential function that I'll be solving, right? So it's a plug-in situation, so I can plug in any value for x. You plug in 0, 1, 2, 3, 4, but please be careful, make sure you look at your graph, right? Your graph doesn't allow you to do certain points, so I'm going to use what I know. I know -2, because you want to use negatives, it's on the graph, right? So it'll be y is equal to 2 to the -2 power. Well, 2 to the negative power is 1 over 2 to the second, which will be 1 over 4, 1/4. And little demo right here, right? Little demo right here. 2 to the -2 power is equal to 1 over 2 to the second, which is equal to 1 to 4. So I can demo and show it because, again, that's why you're here. You want to see how it's done. Gotta use 0. 0 is one of the easiest numbers there, but anything to the 0 power is 1. So excellent, right? And then, of course, guys, great demo. What about a positive 2? So 2 to the second power, of course, is 4. So y is equal to 2 to the second power. You get 4. So now I've got 3 points, guys. I've got 3 coordinate points. I'm going to plot those points and then graph to see what they do. You only need 3 points to graph a line. These aren't lines, not lines. So there's my first one. When x is -2, y is 1/4. So you see I'm right there at the bottom of it, 1/4, not even halfway. Then when x is 0, y is 1. When x is 2, y is all the way up there to 4. So you got like a little curve, and it's growing super fast, right? Now what if I put 4 in there? What would happen? It would just keep getting higher and higher, right? So I'm good with that, guys. That's a graph exponential function. Since the state, the domain, and range, we're going to get to that. Don't worry. Domain being your x values, y is your range value, right? Domain x, range y. Concepts. Let's get these other points because we got a groove going here. When I say we got a groove going, is I'm literally saying, right? We know what to do. Let's plug in a value for x. So we plug in 2. So what do we have? Well, y is equal to the quantity 1/3 all to the second power. Now, what will y equal? Well, think about it. Actually, let's show it. So, y is equal to 1/3 to the second power. So, 1/3 to the second power is 1/3 times 1/3. So, I know that y is going to equal 1/9. So, let's get 1/9 in there. So, when x is 2, y is 1/9. I've got a coordinate point I can plot. What about, ooh, it's not in blue. It'll be in blue now. Pinky blue. And now, 0. Always want to use 0, guys. It's your y-intercept, right? When x is 0, what's y? Well, in this case, again, anything to the 0 power is 1. So, of course, we did positive, we did 0. We can also do the negative. So let's see what happens again when we have a negative exponent. And guys, please remember, as soon as I see a negative exponent, I'm thinking fraction, denominator, it goes in the bottom. So let's work this out. Let's work it out right there. So y is equal to, parentheses open, 1/3 parentheses closed to negative 2 power. So 1 all divided by, and again, I can use the parentheses, but because it has to be to the second power. Now let's take that someplace where we can, see it work. 1 over 1/9, because 1 times 1 is 3 times 3. So 1 divided by 1/9. And you see, this is now again knowing how to divide fractions. 1 times, take the reciprocal, 9 over 1, and you're going to get 9. Wind that, no, just kidding. Or no, I'm not kidding. You need to rewind it. But I got my points. And I'm good. That's what I mean by I like it, guys. I know what I'm doing. I can simplify to find the value that I need. Let's go ahead and plot these out. And we're going to plot it with the red again. Starting at x is 2, y is 1/9. So it's close to 0 as possible, right? When x is 0, y is 1. And when x is negative 2, I got to go all the way up. All the way up. All the way up. Yeah, I know that's simple. So, and of course, here's my curve. And it could be better. Another machine, you get the idea. And of course, even more importantly, your teacher is going to see that you have the coordinates, you have the table, and you showed your work, and I think that's what's most important, right? We didn't talk about domain and range, but it's going to come up. Domain is the x value, range is the y value, so a lot of these, your domain will be all the numbers, however your range has to be greater than 0. But you'll see that, I think I'm focusing on the graphing component right now, guys, and then of course later on, we'll be focusing on domain and range. It's just the values you can use for x and the values you can get for y. Use and get, right? So here's another table, because again, I'm going to use a table to get the coordinates that I'm going to graph for this exponential function. The middle gets your equation, the left is for your x, and of course, I know I gotta have a little nicer than that, right? Clean that up there, B and B. There we go. Oh, there in the pen, made a little extra space. So, boom. All right, and we get the y there. So, again, guys, I can use 2, negative 2, 0. I can use 1, 0, 5. Or I can use something like 3, negative 3, 7, 2. I don't know. I've already decided those are my 3 values. So I need to plug in. Y is going to be equal to 3 times x to the negative 2 power. Again, immediately, my brain goes, that's a negative exponent. So y now is going to equal 3 times, I need a division line. Well, it's going to come up just showing it as a fraction, right? So 3 times 1 over 4. So 3 over 1, right? Times 1 over 4, top times top, bottom times bottom. That's how I like to teach it when I do fractions. So 3/4. So when x is negative 2, y is 3/4. This looks pretty when you fill it in there, right? Just plug it in. You ain't got to show the work. Just put negative 2 in there. Of course, I like it because now I know anything to the 0 power is 1. But that doesn't mean this equals 1. That means it equals 3. And let's see why, right? So let's show a little work here. And I got to show work for my second 2 coordinates. So we're going to fill in y. And we need to show y is 3. So 3 times 2 to the 0 power. The only thing to the 0 power is 1. So 3 times 1 is 3. And therefore we get 3. The next one now, same thing, nothing challenging for me. I can rock exponents all day. 2 to the 2nd power is 4. So 3 times 4. So we give me 12. And now I'm feeling good because all 3 of those points are not foreign to me. I recognize those. Only one that might be crazy is 3/4, but when x is -2, I can easily find 3/4. It's in between 0 and 1, right? But a little bit more than half. So I think I'm gonna clean some things up before I start plotting some points here. But at the end of the day, guys, as we did in 1 and 2, you take those blue values and find them on your graph. What's always going to happen, guys, is you need to see a rapid growth, meaning you should see it start to spike, start to jump up. So I start very low, -2, 3/4, again, not quite 1, but 3/4, 0, 3, and then of course 2 all the way up to 12 already, right? So this is where I think I was like, all right, well, where's 12? I could have did it by 2s, the grid, but whatever, right? But again, I now decided, let me get another point. We're going to plug in 1 for x now. And by plugging in 1, what's going to happen? Let's see. It's right there. You saw it happen, right? 2 to the 1 power is just 2. 3 times 2 is 6. So this helps me in going, let me make my graph a little better by plugging in another point. And now it looks even better. I see that extreme growth, exponential growth. Wow, that's growing fast, right? So, hey, what do you know? I'm doing domain. Look at that. So domain is your x values, guys. Guess what? All real numbers. Do you notice that the red exponential function graph is going to go all the way down and keep going to the left, so you can pick any x value. So keep going up to the right, keep going right, so you pick any x value on the left side of 0 and the right side of 0. For range though, guys, it's not all real numbers. It's only all positive numbers. Because you see how it levels out right there, the y-axis? Oh, sorry, the x-axis? It's not going to go below that. You cannot use anything. You're going to get it. Try it on a graphing calculator. Try out Desmos, excellent website for graphing. And I'm feeling good. We can do that for the next one. I hope so. So for the next one, guys, y is equal to 3 to the x power all plus 2. Now I say all plus 2 because you don't want to say 3 to the x power plus 2 and leave that 2 as an exponent, right? No, you got to take the exponent and add 2. So again, guys, choosing some values. 2 to me seems to be working. I gotta use 0, right? Looks like before I put them in, I'm gonna knock them out though. Y to the -2 power plus 2. Negative exponent? No! So 1 over 3 to the second. 3 to the second is 9, so we get 1/9 plus 2. And to me, guys, don't you mean 2 and 1/9? Yes, that's it. So when x is -2, y is 2 and 1/9. All right. Well, let's choose another value. And this time, guys, let's try to think of what are we always going to plug in when using a table of points? 0. So what's going to happen here, guys? Anything to the 0 power is 1. So of course y is equal to 3 to the 0 power plus 2 just because y equals 1 plus 2. And that gives me 3. So I have my y-intercept wherever across the y-axis. When x is 0, y is 3, right? So keep pushing. Keep pushing. Keep pushing. I plugged in a little incorrectly up there, guys. Shouldn't be an x, it should be a -2, but don't worry, right? We don't ever worry. We're here to get better. All right, and next value, again guys, I use -2, so in my brain, of course, +2. But again, if I wanted to see what happened at 1 or even at 3, all real numbers are good for x, right? 3 to the second power +2, so again, it's going to be 9. +2 will give me 11. So again, it's getting big pretty fast. I started with 2 in one way, 3, and I jumped up to 11. So let's go ahead and get those 3 points on our coordinate plane. Again, guys, -2. So I'm going to go back 2 and then up to 2 in 1/9. Oh, started with the y. Intercept, which is smart. I like it. Good, love it. Y-intercept is 0,3. Yep, we know that. Another easy point, 2, 11. I don't know if I'm doing that one next or doing the first point. We'll find out right now. So there it is, -2, and then just above 2. So 2 in 1/9. Good enough for me. And then of course, +2. I'm going to go up to 11. So this is another situation where do I want some more coordinates to get a more accurate graph? Well, if I do pick one, and I did pick one, I picked 1, the actual value of 1. So this time y is equal to 3 to the first power plus 2. So y will equal 3 plus 2. Because 3 to the first power is just 3. And therefore y is going to equal, come on, 5, you got it. Excellent, I can graph that. I see 1, 5 on this coordinate plane. To the right 1, 1, 2, 3, 4, 5. So now I'm kind of seeing the curve, and I'm happy with it. That's how these exponential functions should look when graphed, right? And yeah. Oh, we missed that dot. That's okay, you still like it. All right, guys, so in this situation, guys, it looks like my domain. Again, those arrows are telling me it's going to go on forever and ever, so it's going to continue to go on that way for all the negatives for x. It's going to keep going up and start drifting to the right, and it's going to be all numbers for positive x. But my range, you see how it's flattening out? Yeah. See how it's flattening out? It's flattening out. So y is going to keep going up in the positive direction, but it's not going to go any lower than what? You see that? It's not going any lower than 2. Y has to be greater than 2. Everything, no matter what you plug in for x, y will never be anything less than 2. Right. So that's the domain and range. I hope that's making sense for you. You know? And I'm just writing it in a way you'll see it in a textbook, right? Depending on your teacher, some don't like solution sets. Some just want you to understand the meaning of it. But d is equal to the solution of all the numbers. The range has values of y is greater than 2. So part 2, right? Because that was all graphing, and now, guys, we just have a table. Table of points. So the same way we were getting a table of points, now they're giving us a table of points, and recognize that there's no equation in the middle of these, right? And they're horizontal. We were doing vertical. So determine whether the set of data shown below displays exponential behavior, right? Yes or no. Explain why or why not. So before I finish with these arrows, I'm going to do a pause. Now we're pausing because what do I need to know if it's exponential? We graphed them. What do I need to know? So this is where I would say absolutely go and reference the textbook. They have a great little paragraph, 3-4 sentences that tells you. And of course, I love doing the skills practice handouts because they match the questions in the book, they match the questions in the chapter review, all of that good stuff. So I'm going to do my best to explain the why or the why not by showing arrows, operations, just things that are going to tell you, no, it isn't, or yes, it is. So remember, it needs to grow greatly, right? So as x increases, what's going to happen to y? It's going to really increase exponentially. Let's see this. Let's get it started. So what's happening with the x value, guys, is they're adding 1. I see that. pattern. What's happening is they're adding one. Now, every time they add one, what happens to the y? Well, it looks like, I see what's happening. Do you see what's happening? Adding one to the top, but the bottom looks like they're adding 3. Why did I put a minus 3? Adding 3, right? So guys, it can't be exponential. By adding, no. And oops. 9 minus 3 is 12. 12 minus 3 is 15. So no, guys, because of the range values. The range values are telling me that it's not exponential. The behavior of the y values, the behavior of y is telling me it doesn't have a common difference of 3. So the common difference of 3, you don't want that, guys. You don't want a common difference. You want that in the top, not in the bottom, right? So there it is. I'm just cracking up because I put minus 3. My editor's gonna have some Oh, there you go. Let's keep going. So 7, what's happening with the x value? Look, you see it, they're adding 4, they're adding 4. Now what's happening with the y value? They added 20, then they added 40, then they added, no, not adding, multiply. 20 times 2, 40 times 2, 80 times 2. So yes, because the pattern in the x value, or domain, right? So here it is. Yes, the domain has a regular, pattern of adding 4. Now the range, I guess I can say it better than that, regular intervals, and the range, right? Interval, pattern, it's just vocabulary. The range also has a common, and here's the word, not difference, right? Factor of 2. Meaning 20 divided by 2, 40 divided by 2, 80 divided by 2, 160 divided by 2. What's the opposite of dividing? Multiplying, right? So that's why when I said times 2, times 2, times 2, I knew it, I had it, I got it. So, moving on to 6, what's happening here, right? Well, are we seeing what we need to see? Well, for our range, for our domain, we're adding 5 each time. That's a pattern, common intervals, it works. Now, I recognize 20 got smaller, 10 got smaller, 5 got smaller, and they divided each one by half. Divide by 2, divide by 2. Again, guys, before it was multiplied by 2, but again, those are opposites. Multiplying and dividing, they're opposites, right? So that tells me, yes, it has a common factor again. For 8, as I'm speeding it up here, guys, no, absolutely not, because as you can see, the ranges 90 to 70 to 50 to 30, I don't see no pattern. I don't recognize how you got that. So I'm just gonna go with the old nope. All right. So as I spin around, I'll give you guys a little bit more attention. Kind of straightforward, straight up. Domain and range we talked about before when we dealt with functions. When I missed it in the beginning, I knew I was going to come back to it at the end here with the complete understanding of, get it with the understanding that domain is your x value, range is your y values, and you can look at the graph and kind of get a good picture of what's happening with all of the x values as it's going up, and of course, what's happening to all the y values because it will hit a ceiling, right? So, short handout. A lot of fun with it. Chapter 7, we're getting toward the end of it, guys. Always thank you for coming. Like, comment, share, and can't wait to see you in the next video.